So there's the time zone map. We went through some examples, although I seem to be in the wrong section. I am in the wrong section, there we go. Oh, I don't have part B. Just grab that. Copy that. Okay, now I've got part B, excellent. And we talked a little bit about Australian time zones as well. So at this stage, you don't have to memorise anything. We will give you the information you need either as a map or as information on the page. So it might say something like Sydney, which is plus 10 GMT, that's 10 hours before Greenwich Meridian time or mean time, or minus 6 would be 6 hours on the other side. So just keep that in mind. You will have a map of some sort on there, so if you need to find a location, you'll be able to use that map to help you just estimate what you should be getting. You might get a map like this, which gives you a bit more of an indication of where things fall as well, so keep that in mind as well. And that's the start of exercise 5C, and we didn't do these ones here, so I'm going to quickly talk about these because you might need to deal with different longitudinal lines. So positions on the globe. I'm going to trip over this cord if I'm not careful, but I'll try to be. And that is the other thing we talked about last lesson, which is that each 15 degrees around the Earth is approximately 1 hour. Now you've seen the time zone map, and the time zones are actually made based on geographical region, not just on a straight mathematical line on the globe. And because it makes sense that you wouldn't want that straight line to go straight through the middle of a city and have an hour different on each side. So the time zones are made and they're a bit curvy and wiggly and they've got square corners and stuff. But you might get a question where you're just told the longitude and you have to approximate the time zones, in which case you have to work out the number of 15-degree increments in between two cities on the east-west line. We don't care about the north-south, only the east-west line, and then that will be an hour for each 15 degrees. So that is something you'll need to know, that 15 degrees is worth an hour. But you don't really have to memorise that either because you know 360 degrees are in a circle and you know there's 24 hours in a day. And 360 divided by 24 will give you 1 hour per 15 degrees. So you don't have to memorise anything. So let's have a look at these examples. Brisbane is on a longitude of 153 degrees east. And Zurich is on a longitude of 8 degrees east. So what this means is that the angular difference between Brisbane and Zurich, here's me being really lazy, B and Z, is 153 minus 8, which equals 143 degrees. And that's wrong, sorry. Let's go with 145 degrees, that's better. So that's my calculation there. Be careful, I've done a subtraction because they're both in the eastern hemisphere. 153 degrees east, 108 degrees east, they're both in the eastern hemisphere, so the difference is 145. If, on the other hand, Zurich was in the western hemisphere, then I would have to do the calculation from Brisbane, which is here, around to Greenwich, which is 153 degrees plus an additional 8 degrees to get into the western hemisphere. So if they're in different hemispheres, I have to add, whereas if they're in the same hemisphere, I have to subtract. Now, we might get a question, I'll take this question a little bit further in a minute, but for now, Brisbane is a longitude of that, Zurich is a longitude of this, so that it's, we want to make a phone call between 9 AM and 5 PM, so it's 145 degrees. We divide that by 15 to work out the number of hours. Hours will equal 145 divided by 15, which is approximately 9.66 hours. Now, last lesson we discussed the fact that time zones are done hourly. There are some half-hour time zones, but not many. Mostly they're hourly. So those hourly time zones imply that when we get to here, we probably should be considering rounding to an hourly time zone. So again, keep that in mind. So we might say this is approximately 10 hours. Now, it turns out that Zurich is actually plus 1 GMT and Sydney's plus 10, so it's actually a 9-hour difference. But if you don't have the map, you don't know that. You just got to work on a rounding situation. And it depends on whether Sydney's in daylight savings or not as well. So 10-hour difference. Brisbane's on that. What time could you call your friend in Zurich? So it's between 9 a.m. and 5 p.m. And for lack of space, I'll move sideways a little bit. 9 a.m. in Zurich will be 9 a.m. plus 10 hours. That's a bad 10. 10 hours in Brisbane. And 9 a.m. plus 10 hours, 9 plus 10 is 19. 19 is 7 o'clock. So you add the 10 and then we subtract 12s until we get back down to a number between 0 and 12. So that is 7 p.m. And of course 5 p.m. will be the same deal. So we do 5 p.m. plus 10 hours. And that's 5 p.m. is 17, plus 10 hours is 27, or you could just work it out. 5 p.m. plus 7 hours takes you to midnight, plus another 3, so 27 is 3 a.m. in the morning. So this will be equal to 3 a.m. But you do have to be very careful here and make sure that you note the next day. Definitely it's between 5 p.m. on that day and 3 a.m. the next day. So 7 p.m. that day and 3 a.m. the next day. So be very clear, if you move to a new day, you don't know what day today is necessarily in this question, but you have to denote that it's the next day. A plane flies from Brisbane to Zurich departing 2 p.m. local time and arriving at 4 a.m. Zurich time, having crossed the international date line. How long was the plane in the air? So the first thing is to convert these times so that they're in the same time zone, and then we can work out how long it was in the air. Also, it crossed the international date line. So we're going to take that into consideration as well. So let's start by converting. Do you want to go to Brisbane or Zurich? Sorry? Zurich. Let's go Zurich time then. So 2 p.m. local time, 2 p.m. Brisbane time. What time is that in Zurich? Any takers? Do we add 10 hours onto it or subtract 10 hours? Is Zurich in front of us or behind us? So in the previous question, we were getting Zurich time and turning it into Brisbane time, and we added 10 hours because Brisbane happens first, the time here happens first before Zurich. And so we added 10 hours. Now to get from Brisbane to Zurich time, we're subtracting 10 hours. So 2 p.m. in Brisbane is 2 minus 10 hours in Zurich. And again, you do that calculation. The way I would do 2 minus 10 hours is do 2 p.m. minus 12 hours is 2 a.m. and then add 2 hours back on. And you've taken away that 10 hours. So there are lots of different ways you can do it, but you need to practice that so you know that you get to 4 a.m. So 4 a.m. Zurich time. It arrives at 4 a.m. Zurich time. We don't know the days, so that plus minus day, we just have to be logically appropriate about that. How long do you think that this plane was in the air for? It departed at 4 a.m. and arrived in Zurich at 4 a.m. Was it in the air for 0 hours? So let's say it was in the air for 24 hours. Now the assumption here is that 2 p.m. local time and 4 a.m. Zurich time, it doesn't say on the same day, but you've probably got to make that assumption. So if you did have to make an assumption, the same day would be the appropriate assumption there. So this plane is departing from Brisbane, it's flying over the date line, so at some point it loses 24 hours, departs Brisbane, loses 24 hours, so it's basically 4 p.m. the day before, and then flies right around to Zurich, and now it's 4 a.m. Zurich time, so it's also lost an additional 10 hours, and that gives us 4 a.m. to 4 a.m. It's taken a day to do that flight, which is probably a little bit unreasonable, although it has gone the long way. Not many planes would depart Brisbane and go into Zurich the long way. Any questions on that? These questions are a bit tricky, but they're not too bad. You just got to take the time to really think them through. Draw a map of the world and write on it. You don't have to draw a map of the world, but if you draw a rectangle like this, and you say Brisbane's down here in Australia, and Zurich's over there, and it crosses over the international date line, it does this. That's the flight that it's taking. And so you can get a bit of an image and impression of what's going on. We've got a minus 24 hours in that situation, and you know that this is 4 AM. It actually arrives earlier, and this is 2 PM, and you can do the calculations from there. So that type of diagram might help you as well. And here's another question that's similar to it, and it's slightly, is it more complicated? No, the only thing I want to say, I'll do this question a little bit later in the lesson, and then you can cover off from 5C. But the only other thing I want to say is just that you need to be a little bit careful, because there might be an assumption that needs to be made as well about which way the plane flies. So if, for example, we fly from Brisbane to Los Angeles, which is an available direct flight. So we're here, and we fly to Los Angeles, which is actually over here on the back. So I'll just turn this around. We're flying from Brisbane to Los Angeles, which is here. Now Brisbane's 153 degrees away from Greenwich, and Los Angeles is about 100 degrees away from Greenwich. But the plane is not going to go 153 degrees and then 100 degrees. It's going to go the short way. So if you work out 153 plus 100 is 253 degrees, well, it's going to be quicker to do the other side, which is 360 degrees minus the 253. So you've got to be a little bit logical about your approach. And if you have to make an assumption about the path they follow, choose the shortest path. So if you find that the longitudinal angular gap is more than 180 degrees, the shortest path is to go the other way. So keep that in mind as well. Okay, so I will talk about this notation a little bit later in the lesson, but for now, if you can dip back into exercise 5C, you've got your formatives there. If you have any questions about that, you're welcome to do that. With those formatives, if you want to at some point, you're welcome to redo